Hello students, in this video we will learn about the denticity of ligands, what it means and how ligands attach to the central metal ion and the examples of mono, bi and polydentate ligands. So this is the must watch for students learning coordination chemistry. Okay, let's proceed. First let's see what is denticity. So denticity is the number of the lone pair of electrons donated by a ligand, or it is the number of coordinating sides of a ligand. Okay, in a simple way we can say that denticity is just a number of number of lone pair of electrons, or we can say it is equal to the, that is denticity equal to the number of sigma bonds, number of sigma bonds formed by ligands. So just keep this in mind, students. So denticity is equal to the number of lone pair of electrons that is donated by a ligand, or it is just the number of sigma bonds formed by the ligand. Just keep this in mind. Number of lone pair and number of sigma bond is the value of the denticity. Okay, now let's proceed to see the types of the ligands. In first we have monodentate ligands, mean the ligand which have only one donor atom, or it donate one pair of electron or form one sigma bond. So the ligands which donate one pair of electron or form one sigma bond are known as monodentate ligand. So these are further classified as neutral, ionic, cationic ligands. So now let's see some examples for the monodentate ligand. So the examples are carbonyl, CO means carbonyl, NO, nitrosyl, H2O, water, that is aqua, C is thiocarbonyl, N is thionitrosyl. So all these ligands, carbonyl, nitrosyl, aqua, CAs, NS, all these are neutral. All these are neutral unidentate ligands. Okay, these are neutral. Okay, now let's see anionic unidentate ligands. This includes all the halogens. So what are the halogens? Fluorine, chlorine, bromine, iodine. So all this comes under the anionic monodentate ligand. Okay, that is anionic means all these ligands consist of a negative charge. And OH. OH is the hydroxo. CN cyano. NC isocyano. Sir, Here you have to put a negative charge because it is an anionic monodentate ligand. NO2, ONO. NO2 can also be written as ONO, in which this is known as nitrito. Nitrito. SCN. SCN means thiocyanate. NCS. Isothiocyanate. So the same thing. So this too comes under a special case, students. So I'll explain it later in this video. Okay. Now here all this comes under all these things. Okay. All these things are anionic ligands because they consist of negative sign. Okay. So all these ligands are called as monodentate ligand because they donate one pair of electron or they form one sigma bond. Okay. So these ligands will be having a denticity value of 1. Okay, remember this. This is something important to remember. Okay, because denticity value will be 1 because it is a monodentate ligand. Okay, now let's proceed to the bidentate ligand. So, bidentate ligand are the ligands which donate 2 pairs of electron or form 2 sigma bond. So now let's see the examples for the bidentate ligand. So the first one is ethane 1,2 diamine. We can represent this as En. So the structure for the ethane 1,2 diamine is CH2, CH2, NH2 and NH2. Okay. So here we will be having a lone pair. So why it is a bidentate ligands mean? Because here the ethane 1,2 diamine donate 2 pairs of electrons. That is, this nitrogen will donate 1 pair of electron and this nitrogen will donate a 1 pair of electrons. So it donate 2 pair of electron and also form 2 sigma bonds. So that's the reason this ethene 1,2 diamine comes into the bidentate ligand. Okay. Now let's see some other examples for the bidentate ligand. The second example will be oxalator. The formula is C2O4 2 minus. C2. The diagram will be, the structure will be COO minus, COO minus. So here also you see, here also it will donate 2 pair of electrons. A negative charge denotes a pair of electron. Okay, so remember that. So here also it donates a 2 pair of electron and will form a 2 sigma bond. So it comes under the bidentate ligand. Okay, another example is we have glycinate ion. The structure is NH2, CH2, COO minus. So this comes under the bidentate ligand because in nitrogen we have 1 pair of electron and this is negative charge. So it donates two pair of electrons to form a bond. Okay, so all these comes under a bidentate ligand because they donate a two pair of electron to form a coordinating sites with the central metal atom. Okay, now let's proceed to the tridentate ligand. So tridentate ligand are the ligand which donate three pairs of electron. Or they form three sigma bonds. Okay, now let's see some examples for the tridentate ligand. Example is diethyl triamine. So the structure for this will be, so if you notice the structure, we have three lone pairs on the nitrogen, right? So these donate three lone pairs of electrons. So this is the reason this comes under the tridentate ligand. Okay. Now let's see what is the polydentate ligand. So polydentate ligand are the ligand which donate many lone pairs of electron. Okay. So the ligand which donate many lone pairs of electron, that is known as polydentate ligand, because more than two, if it donate more than two, it comes under the polydentate ligand. Okay. Okay, now let's see example for the polydentate ligand. We have seen only examples for up to tridentate ligand. We have tetradentate, pentadentate, hexadentate and everything, but it's not that important. For class 12, this is enough. Okay, now let's see some examples. That is EDTA. EDTA comes under the polydentate ligand. It is actually a hexadentate ligand. That means it donates 6 lone pairs of electron. So EDTA means ethylene diamine tetraacetic acid. So this EDTA donates 6 pairs of electron. Okay. So as it is a polydentate ligand, hexadentate ligand, the denticity of the EDTA will be 6. Okay. So the denticity value will be 6 for the EDTA. Similarly, for the tridentate ligand, the denticity will be 3. For bidentate, the denticity will be 2. The denticity denote the how many lone pair of electron that a ligand is donating. Okay, that's it. Okay. Now we have special cases. Let's see the two special cases of the ligands. That is ambidentate ligand. That is ambidentate ligand means the ligand which the two different atoms donate one pair of electron. I repeat, in ambidentate ligand, two different atoms donate one pair of electron. So as it only donate one pair of electron, this comes under what, children? So this comes under what? This comes under monodentate. Ambidentate comes under monodentate ligand because it can only donate one pair of electrons. So ambidentate ligands comes under the monodentate ligand. So I have said earlier itself the examples. That is the examples for the ambidentate ligands are cyano. That is because the cyano can be cyano or thiocyano. Sorry, isocyano. And NO2 minus can be nitro or how it can be ONO, nitro. See, this is a bond, okay? It's not a negative sign. This is the bond. So, a negative sign will come here. Okay. In another one, thiocyanate, SCN, bond SCN, or bond NCS. Here, these two, this is known as thiocyanate, yes, because it is bonded to sulfur. And this is known as thiocyanate N because the bond is bonded through nitrogen. Here also it is known as cyano because bonded through carbon, isocyano because it is bonded to nitrogen. Here nitro and here is nitrito because it is bonded through O. Okay. All these are ambident ligand because why? Why these are known as ambident ligand? Because there are two different atoms. For example, take cyano. In this we have carbon and nitrogen. Here we have nitrogen, oxygen. Here we have three different atoms also. Okay, uh, carbon, sulfur, and nitrogen. But the only atom that will be donating will be the sulfur and the nitrogen, which consist of two different atoms, but donate only one pair of electron. Okay. For example, if you take CN, it donates only one pair of electrons. So all these ligands consist of two different atoms but donate only one pair of electrons. So that's the reason these are known as ambidentate ligand. Okay, now let's proceed to see another type of ligand which is known as the flexidentate ligand. Okay, flexidentate. It's really interesting one. Okay, because this is a ligand in which the denticity is variable. Ligand in which the denticity varies is known as flexidentate ligand. For example, we have EDTA. We have already seen that EDTA is a hexadentate ligand which comes under the polydentate ligand. And another example also SO4. So these are known as flexidentate ligands because these denticity is variable. That is, it varies. We have seen that EDTA is a hexadentate ligand, but this EDTA also can be tetradentate, pentadentate, and hexadentate. Okay, and also this SO4 2 minus can be monodentate or bidentate. Okay, this is like a exceptional. So that's all about denticity of ligands. If you find this helpful, don't forget to like, share, and subscribe to Chemexcel with Nithi for more chemistry made simple. So see you in the next video. Keep learning and keep excelling. Thank you.